Number one, if the equation x plus 10 times x equals 0 is true, which statement is also true according to the zero product property? So the zero product property is one that states that anytime we have a product, meaning things multiplied together, if those two things or more equal out to 0, then one of the factors has to be 0, or one of the things being multiplied has to equal 0. That's the only way that you can get a product to be 0, is if one or all of the things being multiplied are equal to 0. So in this case, what's being multiplied is x plus 10. So we can think of this quantity as x plus 10, and then times x is equal to 0. So one of these or both of these could be 0. So x plus 10 could equal 0, and this whole thing will be 0, or x could equal 0. So zero product property says either x equals 0 or x plus 10 equals 0, and that is option B. Number two, what are the solutions to this equation? So again, this will be, we have a product, right? So we have this thing or this quantity times this quantity. So we know that either of these or both of them are going to equal 0. So if 10 minus x equals 0, the whole thing will be 0. If 3x minus 9 equals 0, then the whole thing will be 0. So then we can just solve for the variable here. So this says negative x, so I'm just going to add x to both sides because negative x plus x is 0. So this side will just be 10 equals x, and then I'm solved for x. So here's one of my solutions. And then in this one, so I'm going to get x alone. So I'm going to undo this subtraction by adding 9 to both sides because negative 9 plus 9 is 0. So I'm left with just 3x on the left side, and then 0 plus 9. Then we have 3 times x equals 9. So we'll undo the multiplication by dividing both sides by 3 because 3 divided by 3 is 1x. So just x. And then 9 divided by 3 is 3. So these would be our two solutions, that x equals positive 10 and positive 3. And we see that as option C. Number 3, solve each equation. So again, zero product property, we see each of these has factors being multiplied. And so you can set the factors equal to 0, or you can just think what would make this 0. So in part A, it feels like it might be easy to just decide what will make the factor 0. So if x was 6, 6 minus 6 is 0. So x equals 6 would be a solution. And in this next one, x plus 5 needs to equal 0. So if x was negative 5 in this one, negative 5 plus 5 would be 0. So another solution would be x equals negative 5. So positive 6 and negative 5 for that first one. In this second one, this first factor feels like it's pretty easy to figure out that this would be a 3. 3 minus 3 is 0. So one solution would be x equals 3. Then we can look at this next factor here, and maybe this one's a little bit harder to decide since there's a fraction here. So we could just off to the side set this factor equal to 0 and then solve this equation. And we can solve this equation by first getting rid of the subtraction. So this negative 6, we would need to add 6. So then we would have 2/3 x plus 0 equals 0 plus 6, which is 6. Then we could multiply both sides by 3 to undo this dividing by 3. And we would have 2x equals 18. Then we could divide both sides by 2 to undo the multiplication by 2. And we would get x equals 9 as our other solution here. Then in part C, again, this second one is maybe easy to decide that x would equal negative 7 here, so that this equals 0. And then maybe we want to solve the equation for this one, because this one maybe is less easy to just see immediately. So then we could say negative 3x minus 15 equals 0. We could add 15 on both sides so that we get the x term by itself, because negative 15 plus 15 is 0. So we get negative 3x equals 15. Divide by negative 3 to undo that multiplication by 3. And negative 3 divided by negative 3 is 1, so just 1x. 5 divided by negative 3 is negative 5, and we get x equals negative 5 for this equation. Number 4, consider the expressions x minus 4 times 3x minus 6 and 3x squared minus 18x plus 24. Show that the two expressions define the same function. So basically, we're going to multiply this out to show that it's the exact same terms as this. And so you can do this a couple of different ways. If you like to multiply using area method, you could do this. And we've got two terms in each one, so we'll need a 2 by 2 box. And so you have x and negative 4, and you have 3x and negative 6, and then you can just multiply. So the area of this little piece would be x times 3x, which would be 3x squared. Then we'd have x times negative 6 for this one, so negative 6x. 3x times negative 4 would be negative 12x. And then negative 4 times negative 6 would be positive 24. And then when you add these like terms together, negative 12x and negative 6x is negative 18x. So this would be 3x squared minus 18x plus 24. You can also, if you don't do area model, you can also just distribute both the x and the negative 4 into these terms. So we want to multiply the x times the 3x, which gives us 3x squared. Then we want to multiply the x times the negative 6, which would give us negative 6x. Then we would multiply the negative 4 times the 3x, which would give us negative 12x. And then negative 4 times negative 6 gives us plus 24. And then we see that we have these like terms here. So we have 3x squared, negative 6 and negative 12 is negative 18x. And you see those again right here. And then that final term is 24. And we see that whichever way we do it, we end up with this exact same expression. Number 5, Kieran saw that if the equation x plus 2 times x minus 4 equals 0 is true, then the zero product property tells us that either x plus 2 is 0 or x minus 4 is 0. He then reasoned that if x plus 2 times x minus 4 was 72, as is a true statement, then either x plus 2 has to equal 72 or x minus 6 has to equal 72. Explain why this conclusion is incorrect. So we know that zero product property means that we have two things multiply or more things, but we have something multiplied to equal 0. It's not the 72 product, right? It's not that numbers multiply to equal 72. It's that they multiply to equal 0, and there's only one way for that to happen, and that's if at least one of the factors is 0. Once you get 72 as your multiple or as your product, there's an infinite number of ways for us to get two numbers to multiply to 72. If we bring in decimals, right? Now, whole numbers, it's less, but 1 times 72, we know that 9 times 8 is 72, and so on, and multiple different ways to get that. So we don't know what the factors look like. So that's one way if you wanted to write out something like that. Another way is you could plug in some solutions here, right? So you could say, all right, if this is true, then you could say that x plus 2 equals 72. You could solve that. and then we would get x equals 70 as a solution. And then we could try that into the original equation to see if it actually works out. And so we would be doing 70 plus 2 and then 70 minus 4. And we would be getting 72 here times 66, and that certainly does not equal 0. So this is not a solution. So you could just show that it didn't work out. Number 6, Andre wants to solve the equation 5x squared minus 4x minus 18 equals 20. He uses a graphing calculator to graph y equals 5x squared minus 4x minus 18 and y equals 20, and finds that the graphs cross at these points. Substitute each x value Andre found into the expression, then evaluate the expression. So if we, let me put this expression here, 5x squared minus 4x minus 18, and I'm just going to write this down twice so that we can plug into here 2 different times and evaluate. So we are plugging in negative 2.39 for this one. And if we do that, we get 5 times 5.7121 for this first part, which gives us 28.5605. And then negative 4 times negative 2.39 is positive 9.56. And we still have that minus 18. And when we combine all of that, we end up with 20.1205. So as we plug in, that's what we end up with for that one. And then if we do it again here, but using 3.19, and then you can type this into your calculator. This first part, you'll square the 3.19 and then multiply it by 5. You should get 50.8805. And then negative 4 times 3.19 would give you negative 12.76. And you have that negative 18. And so when you simplify that or combine that all together, you again get 20.1205. So why did neither solution equal out to exactly 20 here? Because that's what it's saying is at that, and this is because of rounding. So anytime you round, you're going to be slightly off. And so if we had put more decimal places there, we would get closer and closer to being accurate. But without using the quadratic formula and figuring out exact values, then you're going to be slightly off. Number 7, select all solutions to this equation. So I have a couple options here. You can just take and plug everything in your calculator and see which ones equal 343 as you do that in your calculator. Any that do will be solutions. Make sure if you're doing this method that you get parentheses around the term that you're squaring. Otherwise, you can just go ahead and isolate the x squared. And so if we divide both sides by 7, we end up finding out that the x squared portion needs to be 49. And so what number squared gives us 49? And so you might know that that could be 7, or it could be negative 7, right? So if we do 7 squared, that's 49. If we do negative 7 squared, that's negative 7 times negative 7, which is also positive 49. And then another way to write this is by doing the square root of both sides. And so we could say that x equals the plus or minus square root of 49, simplifying that down to plus or minus 7 like we just did. But that tells us that E is also a solution and G is a solution, the plus and minus square root of 49. Now we can't have this negative inside of the root, right? It's the square root of positive 49. So this one is not good, and neither are these. Number 8, here are two graphs that correspond to two patients A and B. Each graph shows the amount of insulin in micrograms in a patient's body H hours after receiving an injection. The amount of insulin in each patient decreases exponentially. Select all statements that are true about the insulin level of the two patients. Part A says after the injection, the patients have the same amount of insulin in their body. And so if we look here, the initial amount in patient A is 200, and in patient B is over 300. So that is not true. Part B, an equation for the micrograms of insulin in patient A's body. It can be modeled by this. So the initial amount is 200. We just looked at that. Then we need to look at the growth factor. So we're going to need to look at how much we have after 1 hour. And so remember, for growth factor, you do the new amount divided by the original. And so we want to look at how much is in this after 1 hour. And we can see that we're cutting each 100 into 5 equal chunks. So each dash is 20. So we're at 120 in the new amount after 1 hour versus 200 in the original. And then we can simplify this by dividing by 10. And then each of these divide by 4. So 12 divided by 4 is 3, and 20 divided by 4 is 5. And we see that that matches. So B is true. C, the insulin in patient A is decaying faster than that in patient B. So we know here that the growth rate is, or the growth factor is 3/5, which is equal to 0.6. So that means that this is decreasing. So this is 60%. So this is decreasing by 40% per hour, or retaining 60% of the insulin. So let's look at this one. So the growth factor here, the new amount, okay, is at 120, 40, 60. So this is at 160 over 320. And this simplifies to 1/2 or 0.5. So that means that this one is decreasing by 50% each time, which is a bigger decrease. So B is actually decreasing or retaining more medicine each hour. And this said that patient A is decreasing by a faster amount. Oh, I'm sorry, not retaining more. Decreasing by more, retaining less, because it's only retaining 50% versus 60%. So this one is going faster. So B is going faster. So this is wrong. And then D, after 3 hours, patient A has more insulin in their body than patient B. So if we take a look here at 3 hours, this patient is like just over 40. And patient B at 3 hours looks to be exactly at 40. So that would mean A has more, okay, just over 40 versus equal to 40. So patient A has more, which is what this says. So that would be true. And then E says sometime between 2 and 3 hours, the patients have the same amount of insulin. So for this, patient B had been higher than patient A, right? So it had been higher this whole time because patient B started with more. And now it's at 40, where this one is just over 40. So at 3 hours, A is higher than B, versus at 2 hours, A was at like just under 80. So let's call it like 70. Let's call this like 75. and this one was at 80 exactly. So at 2 hours, A was less than B. So they flip-flopped places here. And that means that at some point they were equal. So E is true. Number 9, Han says this pattern of dots can be represented by a quadratic relationship because the dots are arranged in a rectangle in each step. Do you agree? Explain your reasoning. So you can certainly have different explanations here. If it was a quadratic relationship, these would be filled in, okay? They wouldn't be like empty squares because they need to be filled in squares for all of the dots in order for that to be quadratic. So I understand what Han is saying, that he sees squares really here, which is what quadratics are. But if we took a look at how many dots are in each step, there's 4 dots in this one. If we count this up, there's 8 dots here. There are 12 dots here. And then there's 16 dots here. And so this, we see that we're actually adding 4 dots each time. And when you add the same number, that means that this is a linear relationship. So it's not going to be quadratic. And again, you can have different explanations. That's just my explanation.